Section 7.7 is our last section from the textbook. For Chapter 7, we are going to do some supplemental material before we take another test. However, this is the last new section before we take a quiz that's coming up on Wednesday. No school Monday, review day Tuesday, quiz on Wednesday. Your quiz will be over section 7.5, 6, and 7. So just this trig stuff we've been doing. 7.7 brings it all together and will also introduce us to the inverse trig functions. So we will use inverse, tangent, sine, and cosine ratios to help us finish solving right triangles. We'll talk about what it means to solve a right triangle in just a minute. For our warm-ups, we are solving for x. When you do this and you have an angle measure and one side of a right triangle, you're going to have to use one of your trig functions. You have to be able to decide which trig function to use. So if this is the reference angle they gave us, the 19 degrees down here, then this 12 represents which side of the triangle? The hypotenuse. And the x represents which side? The adjacent side. Okay, the side across from that angle they gave us would be considered the opposite side. Now this would change a little bit if we were to have angle P instead of angle R. But since this was the angle they gave us as a reference, x is on the adjacent side. Questions about that? Kobe.
What number is it?
19 degrees. Do you want to sit behind Caleb today? Okay, Majay, you're going to have to move your bag. Crochet?
That quiz is it going on this triad?
No, well, yes, it's going on the current triad. So first triad closed on Friday. Anything we've done this week is on second triad.
Wait,
or
it closed
fifth.
It closed last Friday? I thought today's end of the triad.
Oh, is it? I'll have to check. I know grades are due on Tuesday, so I'll check. If today's the end of the triad, then yes, it would go on fourth triad, whatever, the first triad of this semester. I thought it ended, but I could be mistaken. So if the triad closed today, then yes, that would go on today's. Yes.
So wherever the angle's at, so say if we want, I'm just using this example, so this would be value, adjacent would be whatever, like next to it.
Adjacent is next to it, but not the hypotenuse.
This would be like the difference.
Yeah. Okay, adjacent's next to, but not hypotenuse. Not during notes, but notes are up by the red bin. Okay. Other questions about opposite, hypotenuse, adjacent? Any of those things? Okay. So if we have the hypotenuse and we're trying to find the adjacent side, we have to decide which trig function is appropriate. Which one? Cosine. The cosine next to your trig function should always go an angle. So what angle are we using? What angle measure did they give us? 19. Is equal to, adjacent side was labeled, hypotenuse was labeled. Okay. Put our trig function over 1 so we can cross multiply and solve. So x is equal to 12 times the cosine of 19. We use cosine if we have the adjacent side and the hypotenuse. So that's why on the board I left it up from my last geometry class. But yesterday our mnemonic for remembering this was SOHCAHTOA. So the C cosine uses adjacent and hypotenuse. So the trig function and the two sides that are used, that's how we make up that mnemonic. Other questions? Okay. The rest of the work is done by our calculator. Let's round to the nearest tenth since they didn't give us other directions. What do we get? 11.3. We all agree with that?
Yes.
Okay, remember your calculator needs to be set in degrees in order for you to end up with the right number. If somehow your calculator got set to radians or something else, we would need to get changed. Questions on warm-up 1? All right, on warm-up 2, they labeled a 60-degree angle for us. So technically, we have two ways of doing this. One way of doing it would be to use our special right triangles. We'll go ahead and stick with the trig way of doing it for now, just since that's what we've been practicing. In relation to the 60-degree angle, the 9 represents what side of the triangle? The opposite side, and the x represents the hypotenuse. Which trig function should we use? How's that pronounced? Sine. Sine of what? 60. Always put an angle next to your trig function. Is equal to what? 9 over x. Cross multiply and solve. So we have 9 equals x times the sine of 60 degrees. To get x alone, what will we need to do? Divide by sine of 60 on both sides. Okay, then it goes in our calculator. 9 divided by the sine of 60 rounded to the nearest tenth. 10.4. Questions about either of the warm-ups? Need more time? Okay. To solve a right triangle means to find all measures of sides and angles. So you would know every single side length and every single angle measure if you have solved a right triangle. We can solve a right triangle if we know 2 of the sides. It could be any 2 of the sides. Or we can solve it if we know 1 side and 1 of the acute angles. Obviously, if it's a right triangle, we always know that we have a right angle. But if we're going to solve it, we would also have to have 1 of the acute angles if we just have 1 side. So what we've been doing the last couple days is taking steps towards solving a right triangle. We've just been finding 1 piece of information. Today we'll talk about how we could find all the pieces of information. Anybody need more time on this slide? Okay. In order to do this, we need to understand our inverse trigonometric ratios. So if we let angle A be an acute angle, if the tangent of angle A is equal to x, then the inverse tangent of x gives us the measure of angle A. Similarly, if the sine of angle A is equal to x, then the inverse sine of x is equal to the measure of angle A. If the cosine of angle A is equal to x, then the inverse cosine of x is equal to the measure of angle A. Inverse can only be used to find angle measures. We will never use inverse except for to find angle measures. If you think about tangent, sine, and cosine as functions, this should make sense. If you are trying to undo a function, if you're trying to undo a function in any math class, you're using the opposite or inverse operation. Like when we try to undo addition, we use real basic. If you're trying to undo addition, you use subtraction. If you're trying to undo multiplication, you use division. If we have to undo tangent to get angle A alone, we're going to use inverse tangent. This is why it works. If you have the tangent of A equal to X, and you apply the inverse tangent on both sides, then on the left side, inverse tangent and tangent undo each other or cancel each other out. And that's how we end up with just angle A equal to the inverse tangent of X. This is where all of these come from. Okay, if you can understand that, then that will help you build your foundation. Otherwise, you just need to memorize that inverse is used to find angle measures. Questions about this slide? Okay. On we go. Let angle A and angle B be acute angles of a right triangle. Use a calculator to approximate measures of angle A and angle B to the nearest tenth of a degree. So all of the work, so to speak, will be done in your calculator. But I will expect for you to show me what it is you're typing into your calculator to get your answer. So if they start you off with sine of angle A equals 0.87, in order to find an angle measure, we have to use inverse sine. So inverse sine of 0.87. I want to see what it is you're typing into your calculator. To get to inverse sine on many calculators, you have to use the second or shift key. On some calculators, you have to press the sine button twice to get to inverse sine. Does anybody need help figuring out how to get to inverse sine on their calculator? Okay. Excuse me.
Do you want
So you're going to use the second button and then press sine. What do the directions say?
never mind.
Anybody else need calculator assistance? You're going to have to press the second button and then press sine, and it'll give you inverse sine.
And then I put that number in.
And then you put in 0.87. Okay, on yours you're going to put in 0.87, then press second, and then sine. And then I don't think you'll have to press equal to it. Yeah, it's already on there. Caleb.
For fractions, do we have to find the decimal first?
Or fraction. No, you should be able to just type it into your calculator.
Okay.
I mean, you can, but you won't want to round that decimal before you put it in if it comes out to an improper or non-terminating decimal. But it is not necessary.
Are we rounding to the nearest 10?
Yes. So what do we get to the nearest tenth?
60.5.
Okay, so the measure of angle A is 60.5. Because this is an angle, it's measured in degrees. If you're finding an angle measure, you better put a degree symbol on it. If you're finding a side length, you better not put a degree symbol on it. Okay, on letter B, we are going to use inverse cosine of 3/20. You should be able to just type that into your calculator. The only exception to that would probably be those of you that have one of the gray and black ones. You'll probably need to take 3 divided by 20, then press second cosine. But for the most part, it should be able to get typed straight into most calculators. What do we get rounded to the nearest tenth? 81.4 degrees. Anybody have questions, concerns about how we got that? All right, on letter C, we're using inverse sine of 0.24. What do we get for the measure of angle A? 13 point what? Okay. Last one again, we are using inverse cosine of 0.37. And what do we get? 68.3 degrees. Questions, concerns about those? Need more time on that slide. Okay. Use a calculator to approximate the measure of angle A to the nearest tenth of a degree. Okay, so they gave us 2 sides. We are asked to find angle A. If you want to circle angle A, put a little star or an arc mark in it so you know that's your reference angle, that's fine. If you don't need to do that, that's fine. We have to decide which trig function is appropriate to start off with. Then from there, we'll use the inverse trig function of it. So, the 15 represents which side of my triangle? Opposite. The 20 represents which side? Adjacent. So which trig function is appropriate? Tangent. So we should start it off with the tangent of angle A. Always put an angle right next to a trig function. Just the regular, plain, original trig functions. The tangent of angle A is equal to what? 15/20. If I were to just ask you for tangent of angle A, I would want you to reduce that fraction. Since we're not done with this problem, you don't really need to. We don't just want the tangent of angle A, we want to know what angle A is. So what do we have to use? Inverse tangent. So angle A equals inverse tangent of 15/20. If you want to reduce the fraction before you plug it into your calculator, that's fine. Should give you the same answer either way. Rounded to the nearest tenth of a degree, what do we get for angle A? 36.9 degrees. Yes.
I just have a question. I don't know if opposite and adjacent, I think.
So that's why I circle the angle that they tell us to reference. So
Oh.
opposite of that angle is going to be across from it.
Okay, thank you.
You're welcome. Other questions on example 2? Okay. We'll move on. Solve the right triangle. Round decimal answers to the nearest tenth. To solve a right triangle means we have to find all missing sides and all missing angles. So, what is my missing angle that I'm looking for? B. So angle B is something I'm going to have to find. What's one of the sides I'm missing? AB. And the other one is BC. So I'm just making a little list of all the things I need to find. If I find all of those things, then I will have solved my right triangle. I will give you a hint on this one and tell you angle B is the easiest thing to find. Ari?
You can take 180 minus 90
Good. We can find angle B without using any trig on this problem. We know all three angles should add up to 180. Caleb?
I have 48 degrees.
Anybody else get 48 degrees? You should have. You don't even necessarily have to start out with 180. If it's a right angle, these two should always add up to 90. But if you start with 180, that's fine. Just remember to subtract off both known angles. Okay, so we could go ahead and label that. From there, you have some choices. You are going to have to use a trig function, but you need to pick which angle you're going to use as your reference angle. It has to be one of the acute angles. And then you have to pick which side you want to find first, AB or BC. So which angle do you want to use as your reference angle? Angle A? I like using the angle that they gave us originally, just in case I didn't get this one right. Just in case I made a mistake, it's always safe to use whatever information the problem gives you. And then which side do you want to find first? Okay, so I'll label the unknown side with an X. You could use any variable you want, but you just have to pick which side you're going to go for. If I'm using angle A as a reference, X represents which side of my triangle? The hypotenuse. And my 70 feet that I have over here represents the adjacent side. Okay? If I'm dealing with adjacent and hypotenuse, which trig function should I be using? Cosine. The cosine of what? 42. The cosine of that angle is equal to what? 70 over x, adjacent over hypotenuse. Do we have questions about setting up that equation? Caleb?
I did opposite on that one.
Did you use 42 degrees?
Yeah. Like I did and for that one.
Were you finding the hypotenuse or you finding BC?
BC.
Okay, so you're not doing the same problem we're doing. So that would be a different setup. We're not finding BC right now.
I know.
Okay. So no, we probably won't get the same number. The hypotenuse and BC should not have the same measure. When we find BC, yes, everybody should get the same measure for BC. That's not what we're doing. Do we have questions about what it is we're doing? Okay. We cross multiply and solve. We get 70 is equal to x times cosine of 42. To get x alone, what would we do? Divide by cosine of 42 degrees on both sides. From there, our calculator helps us. Directions say to round to the nearest tenth. So what do we get? 24.2. Do we need a degree symbol on that? 94.2. Okay. 90. I was going to say that shouldn't sound right anyway, because our leg was already bigger than that. Okay. So that represented a B. Fill that in on our list. Questions about finding AB? Okay. Technically at this point you have two options for finding BC. One of them is to use more trig. The other one technically would be to use what? Pythagorean theorem. I would lean towards using more trig just because I don't like to reuse any numbers that I had to round. If you reuse rounded numbers, then you are likely to end up with an answer that's not quite right. probably be kind of close, but it might not be close enough to get points or full points. Okay, so to find BC, I would just label that with a new variable like y. And I wouldn't use the hypotenuse in order to find it because we had to round it. So I would always default back to the information that was given to you in the original problem. We have questions about what I mean by that. Okay, so now if we are using the angle that they gave us, we still have this side labeled as our adjacent side. BC that we labeled Y is which side of our triangle? Opposite. So now which trig function is appropriate? Oh, we seem divided. I agree with those of you that are saying tangent. Sine uses the hypotenuse. Yes, we do have a number for the hypotenuse. However, we had to round it. I'm not saying you can't get the correct answer using that. What I am saying is that your answer might get rounded again and be just a little bit different from what it should be. I'm not saying you can't do it. I'm just saying the most reliable thing to use would be the ones they gave you, which would be adjacent. If I'm finding opposite and I was given adjacent, I should be using tangent. So tangent of what? 42 is equal to y over 70. Again, cross multiply and solve. Y is equal to 70 times the tangent of 42 degrees. What do we get rounded to the nearest tenth for y? 63.0. We all agree with that? Okay, it seems reasonable because it is less than our hypotenuse. It's also reasonable because it's smaller than the 70. Remember, the side across from the smaller angle should be smaller than the side across from the larger angle. So then we have finished solving this right triangle. Questions about example 3? Okay. Solve the right triangle. This time, we were not given any degree measures. We were only given two sides. So that means we are going to have to find the measure of angle D, the measure of angle F, and the length of side EF. We do not need trig to find the length of EF. How can we do that? Pythagorean theorem. Now, as I've been grading those tests, it seems that some of us have maybe forgotten just a little bit how to appropriately use the Pythagorean theorem. If I label side EF with an X, and I'm trying to plug into the Pythagorean theorem, what is that going to look like? Okay, so I'll go all the way back to just plugging each side in. You're correct. But I'm going to go all the way back to this because some people have been plugging things in the wrong spots. Some people have been acting like every time you're looking for something, it's the hypotenuse. That is not the case. The hypotenuse is always across from the right angle. So whatever you're plugging into C should always be across from the right angle. Taylor is correct. This does turn into x squared plus 9 equals 81. Subtract the 9. X squared equals 72. Okay, we would get x is equal to 6 root 2. They didn't. Oh, they did give us directions on your paper to round to the nearest tenth, so this would be approximately what? 8.5. Okay, always follow whatever the directions are. Questions about finding EF? Okay, to find the measure of angle D. Again, I would not use anything that you had to round. So if D is our reference angle, the 3 represents which side of the triangle? Adjacent. And the 9 represents, so which trig function is appropriate? Cosine. So the cosine of angle D is equal to what? 3/9. Because we are finding an angle measure, we need to use inverse. So angle D is equal to inverse cosine of 3/9. If you want to reduce that to 1/3, that's fine. It's going in the calculator either way. Rounded to the nearest tenth, what do we get for the measure of angle D? 70.5. Okay. Degrees. Now, if you really wanted to, you could use angle F as a reference angle and use more trig, or you could subtract your 2 angles from 180, or just subtract your 1 angle from 90. Okay, if we take 90 minus 70.5, what do we get? 19.5 degrees. Okay, you can use trig again, and that would be fine, but it's usually quicker to just subtract. Questions about example 4? Okay, we've got one more. A road rises 10 feet in a horizontal distance of 200 feet. What is the angle of inclination? A picture is helpful. If the road is rising 10 feet, that's a vertical distance. The horizontal distance, your horizontal distance is 200 feet. The angle of inclination occurs between the road and what we consider the baseline of the ground. So this would be our angle. I'll just label it with an A down here. You could also think about this as a ramp coming up off of the ground, or a bridge leading up to a bridge, something like that. In order to do this, what trig function should we use? Tangent, because we have the opposite side and the adjacent side. The tangent of angle A is equal to what? 10/200. Because I'm looking for an angle, I need to use inverse tangent. Let's round to the nearest tenth again. 2.9 degrees. So we got a really low incline. Your homework is on your assignment sheet. PSAT is already due. We have a 3-day weekend. We will review on Tuesday, quiz on Wednesday.